Hi, welcome to Shiko Math Practice Lab, Learning Through Practicing. And we are going to our first practice set, number 1, in the unit, Derivative Rules and Formulas. In this video, we're going to talk about how to use the basic derivative formula for the constants, power function, x to the nth power, and the exponential function here. So here is what we're going to do. And first, we're going to take a look at the different formulas and for how to do the derivative to the constants and for the power rule and exponential function. Then we're going to talk about a couple rules here. And then our practice sets here, first we're going to have 6 very, very mechanical type of the problems. We're just going to use those basic rules, try to take a look at the derivative. And then we're going to take a look how do I find the tangent line and the normal line for a given function at a given points here. Okay, so this is kind of application for that. And then this is another tangent line applications here. Then this problems here, this is the very important problem. So we use this a lot in calculus 1. So if they give you a position function, then how do you find the velocity and acceleration functions here? Okay, so those are the problem basically we are going to cover, in this unit here. Okay, so let's go back to our worksheets and take a look here. Okay, so here we go. Okay, so the first things here we're going to talk about is the formula here, right? So we said if this is a constant, so if you take the derivative for a constant, and then this is zeros here, okay? So the power rule will tell you if you have x to the nth power, it doesn't matter n is positive or negative, except so it doesn't matter the n is positive or negative, and then you always can just take the n's out and then the x to the minus 1s here. Then the next ones here we talk about the exponential function. This is for the natural exponential function is the e, so the derivative of the ex will be by itself here. Then in the later when we talk about how about what is the derivative if you have the base is not equal to e's here, right? So then if the base is not equal to e, then what will be the formula? We're going to talk about that later. Okay, so now let's take a look at what type of the rules we have here. So we have the one we call this the constant multiply rule. So what's that mean? That means if you times a constant in front of your function, then you can take this constant out. So basically it will just be like constant. Then you take the derivative of the function. Then the next ones here, we call it the sum rule. That means if you add the two functions together, then you can then you take the derivative. What will be equal to, you just take the derivative separately and then add them together here. Okay, so now let's take a look. Right now we have this very brief review. That's what you learned. So let's try to practice here. Okay, so this one's here, right? So this one, let's see here, the f of x here. So the f prime x is here, right? So will just be what? The powers rule, so to remove the 3 to the front. So what is the top half? It's 3 minus 1s, right? So okay, let's write down it's 3 minus 1. Then minus 4 times 1s, right? Because this is, that means it's x to the first power. Then this is 1 minus 1. So what happened to the 6 here? 6 is what? 6 is constants. So the constant you take derivative is 0. So the final answer, this will be 3 to the x what? X squares, right? Then 1 minus, should be 1 minus 1, sorry, here. So this is a minus 4, right? Because this is x to the 0 power. So that's why the answer here is 3x squared minus 4 here. Okay, let's take a look at this one. Yeah, so here, this is the n, and this is the answer here, right? So let's take a look. So this is y prime will be the n. So this is 5/3. Then what is here? The top here will be what? So it will be the 5/3 what? -1, right? It's -1. Then minus, then you have 2/3 here. Then the x here, this will be the 2/3 -1 here, right? Okay, so then here, this is the 5/3. So what is x to the 5/3 -1? Will be 2/3, right? And then minus this is 2/3. Then what is the 2/3 -1 here? The 2/3 -1 is -1/3, right? So you can kind of combine a little bit. So it depends how much your instructor wants you to combine, right? So this is x to the 2/3 -2, 1/. Now what is here? So this is x to the 1/3 here. You can combine it to find a common denominator, and that will be your algebra skill. So, if you want to do it, you can do it. Or if your instructor is okay with you to just leave like this, then you can just leave like this. So, like in here, so if you do want to combine, so this will be your combined answers, right? So this will be the x to 1/3. Okay, so if it's a common denominators, right? So the f to 1/3. So what is this one going to become to? This will become to 5 to the x, right? And then this is the 2's here. Okay, so you can combine it into here, use the common denominator concept. Okay, so it depends on what your teachers want. Okay, so now here, number 3 is here, the y prime will be what? So remember from the review formula, what is the EX? So the EX is really easy. The derivative will just be itself. Then there's a constant. So there's a derivative is EX here. Okay, so then take a look. What is this one's here, right? So this is really 4 to the x to the what? 1/3, right? Okay, so 4 to the 1/3. And now let's just use the same rules here. So this is plus 4. So this will be your ends, right? So it's 4 times what here? -1/3. And what up here is -1/3 -1. Correct? Okay, so now this will be the 3 to the EX -4/3. Okay, so what is x -1/3 -1? Is -4/3, right? So the -4/3, if you like, you can put it back to the denominator. So this is 4/3. Then this is x to the 4/3. Or if you want to do one more step, you can say this is -4/3. Then you can take the x out, and then this is x to the cube roots here, right? So most likely, I think your teacher will be okay if you live in here, or if you want to go a little further. So either way, so it depends on how much you want to simplify. Okay, so now number 4 here. So how do I do the derivative of this one? So right now we are just using the basic formula of the constants, the power, and EX. So remember, you cannot take the derivative on the top and on the bottoms, right? So the first thing for here, I need to do is I need to change it. So I separate this big fraction to a 3 little fraction here. Okay, so then this one's here, this is x squared, then this is the square root. So what I have here, so this will be what? X to the what? 3/2, right? Because you use your components. Okay, so now this is 4. So x and x to the square root. So what do you have here? X to the 1/2. Now plus 3, this square roots is on the bottom. So what is here? X to the 1/2, -1/2, right? So now you change all of them to each individual power. Then you can use the power rule. So let's try one more time. So the power rule, so here this is 3/2 x here. So what is 3/2 -1, right? then plus 4 times 1/2. And what is here? This is 1/2 minus 1. Okay, so plus 3 times negative 1/2. So what is here? Is negative 1/2 minus 1, right? Okay, so let's simplify it a little bit. So here, basically I want to test your, you know how to do the fraction minus, right? So this is x3/2 minus 1 is what? So this is x1/2. Then 4 times 1/2 is 2. So what is x to the 1/2 minus 1 is negative 1/2, right? And then 3 times the negative 1/2 is 3 to the negative 1/2. So what is negative 1/2 minus 1 is negative what? 3/2. All right, so that will be, like I said at the introduction video, all the problems, in this unit are pretty mechanical, okay? Okay, so now let's take a look here. Number 5 here, right? So y equal to the ex plus 1. So the formula we know is, if I know how to take the derivative for the ex, right? But now, that's what is the formula tell me. But now in here, I have ex plus 1, see here. So in order to use the ex formula, I need to do something about it. So I can change this stuff. So the ex plus 1, I can say is ex times e the first power plus 1, correct? Okay, so now for the e the first power here, so what is this? This is the constant, it's 2.7127 something, right? So it's a constant. Okay, now I can use the formula. So the y prime, so the first term will be a constant multiplies a function. So based on our rule, so it will just be the constants times the derivative of ex. So what is the derivative of ex? It will just be itself, right? Now what happened to this constants? This is a plus 1, so it will be what? It will be 0. So what is my y primes here? The y prime will be e and the x. So if you combine the back, it's e the x plus 1 here. Okay, now let's take a look at the last ones here. So this is the negative 12 over s to the 5th. So in order to use the power rule, I need to change that. So I know this one here is 12, negative 12. Then S5 on the denominator really is what? It's negative 5, right? So now I can use the power rule. So this is my power here. Okay, so what is the power rules here? So I will have a prime s here. So it's equal to negative 12 times what? Negative 5. Then here is negative 5 minus 1. So negative will give you what is 60 times what is here? This will be the s to the what? S to the negative 6, right? Okay, so now I can write like a 60 over s to the 6. That will be the derivative. All right, so those 6 problems are very mechanical. I just want you practice the 3 basic formula we just talked about here. Okay, so now let's take a look at these ones here. So let's say find the equation of the tangent line at the curve. Okay, so find the tangent lines here. If you still remember when we do the definition about the derivative, what is the tangent, what is the derivatives mean? So derivative is what? Is the slope of the tangent lines, right? So I need to first say the y primes here. So the y prime, so this is x4, so it's 4x what? 4x squared minus 2 times 2 is 4x minus 1, right? So then when the x equal to 1, right? So because they're going to passing through this point, right? So when the x equal to 1, then my y prime will be 4 times 1 to the cube minus 4 times 1 and then minus 1. So what is here? So this is negative 1. Like we say, the derivative, so what is the derivative at the value here? So we say it's very, very important. What is that? So this is the what? This is the slope of the what? of the tangent line. Correct? Do you remember that when we in the previous unit? Okay, so now I have the slope, I have a 1 point. So let's take a look. Do you guys remember in the algebra, what is the slope and the 1 point form to get a line? So if you have a 1 point x1, y1, so what is the slope and the 1 point? So we say is y minus y1 is equal to the m x minus x1s, right? So now in here I can say y minus 2. What is the slope here? Ha, it's -1. It's -1 x minus 1 here, right? So then this is x1 plus what? So this is a -1, and this will be +1 here. Right now you add 2 both sides. So my answer is -x plus what? It's x plus 3 here. Okay, so now this is a very good problem because we know we keep emphasize what is the derivative, that's the slope of your tangent line at a specific point, right? Okay, let's take a look at number 8. They say, I want to find the equation. First, they say, hey, I want to find the equation of the tangent line. And here, I want to find the normal line. See here, what is the tangent line and the normal line? So we know tangent line is the slope of the, the derivative is the slope of tangent line at that point. So what is the normal line? So normal lines is like, if this is your tangent lines, right? So the normal line is the one, is perpendicular to the tangent line. So this is what we call this, the normal line. So some people, they don't remember this definition. That is, all right? Okay, so the first, we still need to find the tangent line first, all right? So let's take the 1 prime is equal to the 4x cubed, correct? Then plus 2, the ex derivative is what itself. Now we want to see when the x equal to 0, what is my y prime? When x equal to 0 is 4 times 0 to the cube plus 2 the e to the 0. So e to the 0 is 1, so this is 2. So this is what is 2. So what is the 2 again? Very important, right? So the derivative is slope of the tangent line, so it's the slope. So then we can use the same ideas here, the tangent line for given slope. Okay, so this one is here is a tangent line. So we have the slope and the given point. So we have y minus 2. What is the slope? It's 2 the x minus 0. So this is 2x. So what is the tangent line here? So the tangent line will be y equal to the 2x plus 2. Okay, now I'm going to do the normal line. Okay, so what is the slope of the normal line? Because we know from algebra, if two lines, they are perpendicular to each other, right? Then the slope of the one line will be the reciprocal of the other line with a negative sign. So I know the slope of the normal line is in here will be what? Will be the reciprocal is 1/2. Then it's a negative, right? So it's a negative. Okay, so now I can know the normal lines here, it will be, so still is y minus 2. So what is here is a -1/2 x minus what? X minus 0. Okay, so this is a -1/2 of x. So you add 2 both sides. So this is -1/2 x plus 2. Okay, so this example show you how to find the normal line and the tangent lines, right? So remember the normal line is the line perpendicular to the tangent lines here, right? So if you don't remember, don't know how to do, probably you don't understand, you don't know this definition. You forgot about this definition. Okay, let's take a look. Okay, so now this is still is the same, similar things, all right? So let's say I want to find the point on the curve when the tangent is horizontal here, so they try to test you horizontal. What's that mean? So if a line is horizontal, what's that mean? That means what is the slopes here? The slope will be equal to 0, right? Because the horizontal, that means if you have some line like this, so the slope will be equal to 0. Okay, so now in order to do that, so the first things I need to find the derivative because the slope is you need to find a derivative. So the 2x3, so move the 3 out, so it's 6x squared. And the 3x squared, so move the 2 down, so it's 6x. And the minus 12, 1 disappeared, right? Okay, so because the slope equal to 0, that means this number equal to 0, correct? Okay, so when this number equal to 0, so I can factor the x6 out. Okay, and then what I can do, I can factor it. So what is the x here? So x equal to 1 and x equal to negative 2. So I know when x equal to 1, and the x equal to negative 2, then the tangent line's slope will be equal to 0. So that's what I'm going to get horizontal. So the reason why this is you set it equal to 0 because the horizontal. So because it's a horizontal lines, right? So the horizontal tangent line, so that means the slope equal to 0. That's how do you do that. Okay, so now they want to see, so the point is here, they want to see what are the points, right? So when x equal to 1, you substitute to the y. So what do you get a y here? You substitute 1, so you get a 6, negative 6, I think. Yeah, it's negative 6. Then when the x is equal to negative 2, you substitute to the y. So what you're going to get the y's here is 21. So you're going to have 2 points at this graph. One is 1, negative 6, and the other one is negative 2, 21. The both, the probably function like this. So like both those two will be the horizontal tangent line here. To get that? Okay. So now our last problem here, like we talk about the last problems here, we're going to see a lot of those problems, those type of the problems here. So here we need to know here, right? So the typical, we have 3 type of the function. We have we call it a position function. That means where your particle at, and after t seconds here, this is what we call it st. So the position function, so then the next ones we have, we call it a velocity function. So the velocity function is the first derivative of the position function. Typical, we use the vt to represent a velocity function. Then the next ones here, we call it the acceleration function. So the acceleration function is the second derivative, is a double derivative of the position function. And typical, we use AT to represent. And after we go through this, we're going to have more application problem. Then we're going to go detail about what is the velocity mean and what is the acceleration means here. So like right now, we just give the definitions, right? So remember, right, velocity is the first derivative. And the acceleration is what? Is the second derivative, right? So now they said, okay, what is the velocity if they give me the position function is here? So you say, oh, vt is here, will just be the first derivatives, right? So will just be, you move the 3t squared minus 3, right? And then the acceleration function will just be the second derivative. That means you take the derivative of the first derivative. So what is here is 6t here, okay? So now the next thing here, they said acceleration after 2 seconds. So basically they want to find A2. So what is the A2 here? So it's a 12. And so the units here is meter per second square. And so this is, if you if you had some basic physics, so you know why this is put this meter squares here. And then the next one here is the acceleration when the velocity is 0. Oh, okay, so that means I want to find the t when the velocity is equal to 0, right? So I set the vt equal to 0. That means 3t squared minus 3 equal to 0. So the t squared equal to 1, and the t equal to 1 and the negative 1. And we know, for a particle moving, we cannot have negative times, right? So t is equal to 1. So I know when at 1 second, this particle, the velocity is equal to 0, and then I want to find what is the acceleration. So basically, you want to find a1. So what is the a1 here? Is 6, right? So it's 6 meters per second square. Okay, so that's it. And so this is our first practice set. We basically practiced our fundamental theories, right? So we have the fundamental formula, very basic formulas here. And then we saw the several applications, and we had like 3 problems about the tangent line, slope, those things. Basically, this is try to tell you, what is the slope of the tangent line at a point? That's the derivative, right? So they try to emphasize and drive in that concept. Then the second part is very important, is they start to introduce, this is one of the widely used application for the derivative in physics. So it's what is the position function, what is the velocity function, and what is the acceleration function. All right, and that's it. So this is our first practice set about the use of the very basic formulas and rules. Okay, so the next video we're going to talk about the one interesting rule. We call it the product rule. All right, so that's it. It's nice to talk to you in this video, and I hope you enjoyed it. And so have a good day, and I will talk to you in our next video. Okay, bye.